Hello everyone, welcome back to the maths class. We have started the chapter integration and in exercise 7.2 we have done some questions. Today we will continue the same exercise and we will do some different questions. So let's start. The first question is integrate e power 2x minus 1 upon e power 2x plus 1. Here in this question there is no function whose derivative is in the numerator or numerator's derivative in the denominator. We can't put any function to the third variable because in this exercise we are doing the questions by substitution method. So what we will do in this type of questions, we will divide numerator and denominator by e power x. e power x in numerator and denominator को divide करके what you will get e power 2x upon e power x minus 1 upon e power x e power 2x upon e power x plus 1 upon e power x into dx. What you will get? Its power will subtracted from the numerator's power, so it will be e power x minus e power minus x e power x plus e power minus x. Now check over there, the term in the denominator, its derivative lie in the numerator. We can put here e power x plus e power minus x is equal to t. When you will take the derivative of the exponential function, the first of all exponential function is same and derivative of its power. Derivative of its power x, we are differentiating with respect to x, so derivative of x is 1. Same here, e power minus x as it is and derivative of minus x is minus 1 is equal to dt by dx. What it will be? E power x plus minus minus e power minus x and dx cross multiply here, it will be dt. So value of this e power x minus e power minus x is dt. So we can write dt by t. In the denominator there is a linear function and its integration will be equal to log of t plus c. Put here value of t e power x plus e power minus x plus c. This type of question you can solve like this. What we have done? Divide numerator and denominator by e power x. We will get in the numerator e power x minus e power minus x and in the numerator e power x plus e power minus x. Now we will put the denominator e power x plus e power minus x is equal to t and get the derivative, the term in the numerator. It will be dt by t, the answer will be log t plus c and we will put the value of t. Yes. Look at the another question. Ten square 2x minus 3 into dx. And we know that there is no integration of tan square x. integration of tan x is possible, integration of secant square x is possible, secant square of cosecant square is possible. First of all, we will convert this tan square x into secant square x. We have the identity secant square x minus tan square x is equal to 1. From here we will get secant square x minus 1 is equal to tan square x. So it means this tan square x we can write it as secant square x minus 1. What is the x? X is the angle, 2x minus 3. We can write it as secant square 2x minus 3 minus 1 into dx. We can separate these terms. Secant square 2x minus 3 into dx minus 1 into dx. Here the secant square x integration is tan x, and in the denominator we take the derivative of this angle, that is 2, and derivative of 3 is constant, its derivative is 0, and dx integration is x plus c. This will be the answer. So always keep it in mind, if there is tan square x, you have to convert it in the form of secant square x. So you can use this identity and write like this. Same here, if the question is there cot square 2x minus 3, then again you have to convert it into the cosecant square x minus 1, because cosecant square x minus cot square x is equal to 1. From that identity you can find cosecant square x minus 1 is equal to cot square x. So let's see the another question. Next one. Two cos x minus 3 sin x upon 6 cos x plus 4 sin x. Now look in this question. Here, if we will put this value in the denominator is equal to t, and we can take 2 common from here, so what it will be? It will be 3 cos x plus 2 sin x. And if we will put this value is equal to t, so we will get this numerator as its derivative. How? So let's put 6 cos x plus 4 sin x is equal to t. What it will be? Derivative of cos x is minus sin x. It will be minus 6 sin x, and sin x derivative is cos x into dx is equal to dt. Now take 2 common from here. What it will be? 2 to the 4. 2 cos x minus 3 sin x dx is equal to dt. So it will be twice of cos x minus 3 sin x into dx is equal to 1 by 2 into dt. Cross multiply this 2. Now we get in the numerator it will be 1 by 2 into dt. So we can write it 1 by 2 into dt by t, and in the denominator there is a linear term. What is the integration of linear? If it is in the denominator, it will be log t. So you can write here 1 by 2 into log of t plus c. Now put the value of t. 1 by 2 log of 6 cos x plus 4 sin x plus c. Questions are very easy. you have to just identify the term whose derivative lie in the statement and then put that value as the third variable and get their value and then do the integration. Let's see some another questions. Today we are doing some different questions, but the method is same. You should also do the practice from the reference book, Elements of Mathematics, R.D. Sharma, whatever you have. And you can ask the question on my WhatsApp number anytime. Now another question is 1 upon cos square x into 1 minus 10x whole square. 10x whole square. Now there is cos square x, there is 1 minus 10x whole square. So 10x derivative is secant square x, but there is cos square x. But we know 1 upon cos square is secant square x because cos is reciprocal of secant and secant is reciprocal of cos. So if there is 1 by cos square x, we can write it as secant square x dx upon 1 minus 10x whole square. You can put this value in the denominator. 1 minus 10x is equal to t. 1's derivative of 1 is 0. 10x derivative is secant square x dx is equal to dt. Secant square x dx is equal to minus of dt. You will put here negative of dt upon t square, but there is no linear term in the denominator, so you can't take the integration as log t. So you can write this value as t power minus 2 into dt and then do the integration. Add 1 to its power, same number in the denominator, plus c. What it will be? Negative t power minus 1 upon minus 1 plus c, negative negative positive, and you can write it will be 1 by t plus c. Now you can put here the value of t. What it will be? 1 by 1 minus 10x plus c. That will be its answer. In this type of questions, you have to check that how you can make the derivative of 10x as secant square x. So 1 by cos square x, you can write secant square x and then put 1 minus 10x is equal to t and get the answer. Now there is a question, cos of root x upon root x. In this type of questions, always keep in mind that you can put the angle of the trigonometric function as t, because root x derivative is 1 by 2 root x. That's why we will put root x is equal to t, not the cos. If there is a function with sine root x, then you can put cos root x complete function as t. So you can write here, let root x is equal to t, its derivative will be 1 by 2 root x dx is equal to dt. 1 by root x into dx is equal to twice of dt, cross multiply. In the last video, I already told you that how you will get 1 by 2 root x. Take its power 1 by 2 and then simply do the differentiation. You will get the same result. Now what it will be? It will be cos t and 1 by root x dx is equal to dt. Do the integration. Cos t integration is sin t plus c. Put here the value of t, that is root x plus c. Now there is a question. Next question is cos x upon root 1 plus sin x into dx. How you will do this type of question? It's very easy question. Because 1 plus sin x, its derivative is cos x. You can put this value as t. 1 plus sin x is equal to t. It will be cos x dx is equal to dt. So it will be dt by root t. And now do the integration. Its power is 1 by 2. You can write it as t power minus 1 by 2 into dt. Take its integration, minus 2 plus 1 plus 1 by 2 and again 1 by 2, it will be 2 by 1 plus c. Put here the value of t, twice of root 1 plus sin x plus c. This is very easy question. Now cot x into log sin x. Cot x into log of sin x. Yes, this question is very interesting. Which function we can put as the third variable t? Cot x, if we will put cot x is equal to t, so you can't get the derivative log sin x. Always keep in mind the value of the function which has the log you can put as t. The log of sin x is equal to t. How you will take its derivative? First of all 1 upon sin x, and sin x derivative is in the numerator, that is cos x, and dt by dx cross multiply, it will be dt. Cos by sin is cot x into dx is equal to dt. You will get cot x into dx as dt. What it will be? This function is t and cot x dx is dt. You can do its integration, t square by 2 plus c. Put here value of t log sin x whole square by 2 plus c. Now the next question. Sin x upon 1 plus cos x. This question is for you. We are looking here 1 plus cos x. If we will put it equal to t, so you will get derivative that is in the numerator. Cos x derivative is minus sin x dx is equal to dt. So you will get minus dt upon t. So you will do this question yourself. Right. Put here 1 plus cos x is equal to t. So you will get minus sin x dx is equal to dt. So sin x dx is equal to minus of dt. Complete this question yourself. Now there are two questions which are very interesting. Both questions are same. Understand the concept, how you will write the function integrate 1 upon 1 plus 10x into dx. We haven't any formula to write 1 plus 10x. So what we will do? We will first of all convert this function in the form of sine and cos. So you can write here 1 upon 1 plus 10x is sine x upon cos x. Take its derivative. 1 upon cos x plus sine x. And this cos x shift to the numerator. Cos x upon cos x plus sine x. Now again check in this question that there is no function whose derivative lie in the statement. You will put sine x, cos x as t, no derivative is there, minus sine x, the single term. You will put denominator as t, you will get minus sine x plus cos x. There is no other another term. So how we will solve this type of questions? First of all, you have to multiply and divide by 2. 2 multiply and divide it by 2. Multiply and divide by 2. So what you will get? Twice of cos x. Now you have to write this term in the form of denominator. How? You can write it as 1 by 2 of cos x plus sin x, cos x plus sin x plus cos x minus sin x upon cos x plus sin x. When you will open the bracket, so what you will get? Positive sin x cancel with negative sin x. So what you will get? Cos x plus cos x, twice of cos x. So in this way you can write twice of cos x. So now you can separate these terms. 1 by 2 cos x plus sin x upon cos x plus sin x into dx. Then again this 1 by 2 multiply with the next term, 1 by 2 of cos x minus sin x upon cos x plus sin x. So here numerator and denominators are same, you can cancel this term. You will get only 1 into dx. You are getting 1 by 2 into dx plus 1 by 2 of cos x minus sin x upon cos x plus sin x into dx. This question is very important question. And now here its integration is x, so you will get x by 2. Here in the denominator, if we will put this value as t, so you will get cos x minus sin x. You will get the derivative in the numerator. So you can put denominator as t and you will get the derivative. So it will be dt by t. So now 1 by 2 into dx integration is x plus 1 by 2. You can put this value as t, cos x plus sin x as t. What you will get? Minus sin x plus cos x into dx is equal to dt. So this function in the numerator it will be dt and denominator is t. So you will get dt by t and its integration will be log t. Log of t. Now put here the value of t. Log of cos x plus sin x plus c. What we have done, first of all, in this type of question, you have to convert the whole term in the form of sin and cos. Then you will multiply and divide by 2, and twice of cos x you can write like this in the form of denominator. So cos x plus sin x plus cos x minus sin x, and then separate the term and then do the integration. The same type of question, if there is at the place of 10x, suppose there will be a cot x, the method will be same. So try yourself. I am writing the statement there. If there will be 1 plus cot x, the method is same. You can write it as cos x upon sin x. Again take the LCM, again you will get sin x plus cos x, and this sin x will shift to the numerator, sin x. This sin x shift in the numerator, and again you will multiply and divide by 2. So how you will write 2 sin x? So if I am writing there with negative sign, like this, so what you will get? Then you will open the bracket, minus cos x cancel with cos x, there is negative, positive, sin x plus sin x will be twice of sin x. So you will get the same term twice of sin x. Now again the same method is there. You have to separate these terms, cos x plus sin x upon cos x plus sin x, and there will be a negative sign, that is minus 1 by 2. Next term is same. Only you will write there the negative sign, and again you will put the same function as t. You will get derivative in the numerator, cos x minus sin x, and again integrate it, you will get the same answer. Clear? Both the questions are same. The next question is x plus 1 into x plus log x whole square upon x into dx. Think it. Which value we can put as t to get the derivative? If you will put x plus 1, so x derivative is 1, but this 1 upon x you can't get by putting any value. So you can put this value x plus log x as t. X plus log x as t. Now take its derivative. 1 log x derivative is 1 by x, dt by dx, dx cross multiply, you will get this. So you can take LCM, x plus 1 by x dx is equal to dt. Now look in the term, x plus 1 by x, this term, x plus 1 by x dx, that term will be dt and it will be t square. So you will write here t square into dt. Its integration t cube by 3 plus c, put here the value x plus log x whole cube by 3 plus c. Do more and more practice, and the question You can solve very easily, but the condition is you should write different type of questions from the different books and understand the concept. How to make the derivatives, how to identify the terms which have the derivative in the statement. Now there is x cube. The next question is integration of x cube of sine of tan inverse x power 4 upon 1 plus x power 8 into dx. This question is very interesting question. Always keep in mind that integration of inverse function is not possible. It is possible only by the product formula. But here in this question we are not using the product formula, because there is a one term that also lie in the denominator, and in the numerator there is only a single term, so we can't separate these terms. If there are two terms or two or more terms in the numerator, then you can separate it, but we can't separate it. We have to put the function so that we will get the derivative. We know the tan inverse x derivative is 1 upon 1 plus x square. But here if there is x power 4, so what will be its derivative? 1 upon 1 plus x power 4 whole square. So write here, let tan inverse x power 4 is equal to t. You have the derivative of tan inverse x is 1 upon 1 plus x square. So what is x? X power 4. It's a whole square. This is the derivative of tan inverse x. But here the angle is x power 4, so we are writing x 1 plus x power 4 whole square. Now take the derivative of this angle in the numerator. So derivative of x power 4 is 4 into x cube, and dt by dx cross multiply, you will get dt. Now look at the statement, x cube upon 1 plus x power 8. So here x cube upon 1 plus x power 8, 4 to the 8, and this 4 you will cross multiply. So you will get here x cube upon 1 plus, here by the exponent's rule, 4 to the 8 into dx is equal to 1 by 4 into dt. So you will get x cube upon 1 plus x power 8 is equal to 1 by 4 into dt. 1 by 4 you can take outside the sign of integration. And what it will be? This is t, the function is sine, so it will be sine t. Sine of t into dt. Now simply do the integration. What is the integration of sine t? That is minus cos t. 1 by 4 into minus of cos t plus c. Put here the value of, with negative sign, cos of t tan inverse x power 4 plus c. Now we will see one more different type of question. Integration of tan x power 9 plus tan power x into log of 10 upon x power 10 plus 10 power x into dx. This is MCQ question, but I am not giving you the options. You have to solve this. So how we will solve this type of question? First of all, always